How's everyone today? Doing good? All right. Ready to get started? Okay. Sounds good. Thank you. All right. Some good news. My tooth is still alive, so at least good. Yeah, they didn't have to take it out. So 3 hours surgery, though, to take off the old crown, do a new root canal. Any of you had a root canal yet? Probably too young, which is good. Yeah, you don't, if you watch your teeth, don't eat, yeah. Floss. I don't always floss. I hate flossing, but that was, things get down in there, and that was the problem. So, uh, and also I've got these hearing aids now. I used to like to listen to loud music. That kind of probably did some things here, but two things health-wise. So we are on our last segment, our last section before the exam. Next Tuesday we will have a full day for review. I'll work through, and I've seen the exam, so there's a few things that we will work through next Tuesday. So that's going to be a good one to either be here or watch the recording of it, because I'll do some specifics I wasn't aware of. I was looking at the exam. I go, yeah, we did this stuff? Okay, yeah, it's not too bad. So we'll go through it. So it'll be exponential and logarithms and this beginning of trigonometry that we're doing to include this part here. So I just wanted to make sure. So today we're doing 4.4. There's some resources there, but also there's exam 2. There is we'll go over this a little bit, but there is a formula sheet that is provided, and that formula sheet has has a template for the unit circle. So what I want to, maybe over the weekend it might be good to practice. This video is about 22 minutes, and I do what I did in class. Basically, I walk around and do all the degrees measures, and then I do all the pi measures, and then I put all the values in. So it's a little, you might want to watch it at twice the speed, and you might be able to keep up just fine. But print this out or have it on, get a piece of paper and practice yourself a little bit, because we don't give you the unit circle for the exam, but we give you a template, and I would suggest fill it out at the beginning. And once you follow the video, it basically says if you can count 1, 2, 3, you can get all the values. So just kind of practice that a couple times, and then that way when you first get into the exam, 2 or 3 minutes, you'll be able to create your unit circle so that when you need to use it, it's there. Okay. There's also a formula sheet. So I'll click on this, and so these are the formulas we're going to provide you, so you don't have to memorize them. So as you're preparing, I'd maybe print that out and have it next to you so that you know what you can use. Yes.
Are the questions that are on the formula sheet, are they going to be like the ones in the exam similar?
There are no questions here. So yeah, so this is just the formula sheet. There was initially there was a brief time where there was some, but those were from something else. So just go with this. Okay, so that'll get you prepared. But then let's go ahead and get into. This is module 18 in my other class, but it's section 4.4 for us. Oops. Let me get this. So now we're going to focus on how to do trig with any angle, of any measure, of any radius. But we tie it back to the XY coordinate system. So first of all is we've got this XY, so this is a, what we call the first quadrant. Notice that both x and y are positive over here. Second quadrant over here, bless you, x is negative, y is positive. Down here in the third quadrant, x is negative, y is negative. Third quadrant. And then over here in the fourth quadrant, x is positive, so this is the x-axis, this is the y. X is positive, but y is negative. So this is kind of what we're working on. We still form triangles in each one, so we measure our angles from here being 0 degrees and also 0 radians. And as we come from here, this would be the angle. But when we do our trigonometry, we still create a right triangle. So this ties back to, we're really using the techniques that we used in the last lecture, which was recorded, of getting these ratios. So notice though, there's a connection between the coordinate point, the point that this ray goes through, formed by the, that the angle goes through. The x coordinate comes right here, will give us one side of the triangle. The y coordinate gives us the other leg of the triangle, and the radius of the circle that it comes from always gives us the hypotenuse. So they all set up like this. And again, if you haven't done the measure triangle activity, or at least viewed the video, I recommend you do that, because you'll see me, if you can't get them printed out, at least you see me flipping the triangle. So that's going to help with this lesson particularly, because we get into something called a reference angle, and it's basically, if you can visualize these triangles, this triangle could fit in any of these quadrants, but it flips around. The right angle is always over there. Okay. Something we see from the Pythagorean theorem, that we get that x squared plus y squared is always going to be equal to r squared in this case, because of that point where the r is the hypotenuse, it's a right triangle. So from these, getting the triangle set up, we can get all the trig functions, maybe starting with sine. Sine is going to be and again, this is the angle we're talking about, at least the reference angle. Theta is measured from 0, but this is our angle. So opposite over hypotenuse, so that's going to be y over r. That's going to give us the sine of the angle, sine of theta. Cosine of theta is going to be adjacent over the hypotenuse, so that will be the x over r. And I think a little bit later we get into polar coordinates, and you'll kind of see a connection between that. The other function that goes with sine is cosecant, and that's the reciprocal function, so that's going to be r over y. Cosine goes with a function called secant, that's its reciprocal function. That's going to be r over x. And then we have the ratio functions, which are tangent. Tangent is sine over cosine. So you could think of it as, it ends up being just y over x. And the cotangent is going to be, again, this is opposite over adjacent. Cotangent is a reciprocal. It's going to be x over y. Okay, so those are our 6 functions, and so we can do trig of, as long as we know what the coordinate endpoint is, we can do it all. If they just give us the coordinate, we can get x and y. We can figure out what r is from this thing here. And again, you'll see we'll do this again when we talk directly about polar coordinates. So that's the nice thing about trig, is it's all sort of interconnected. And what we learned today, we just relearn it and use it again in a different setting, calling polar coordinates, but that'll all fit. Okay, so let's do an example. Find the exact value of each of the 6 trigonometric functions of theta if negative 4, 3 is a point on the terminal side of theta. So where is negative 4, 3? Well, that's x is negative 4, y is positive 3, so I don't know, we'll call this, it would be maybe about here. So it is in the second quadrant. We draw in our triangle. This would be theta, measuring from the beginning. However, we're going to see we could also use this little angle here, which is 180 minus theta, right? So that's getting at what the reference angle is. We'll see that those will give us the same values because they really come from the same triangle. So we know that this endpoint here is negative 4, 3. So we know that x is negative 4, so this side is negative 4, this side is positive 3. And when I set up the triangles, when you set them up, if you put, even though a length of a triangle can't be negative 4, right, because it's a positive, we put it there so it fits in the coordinate system, so that when we do our ratios, we get the right values. Okay, what are we missing? We just need to know what the hypotenuse is, right? And so to get that hypotenuse, we use the Pythagorean theorem. Negative 4 squared plus 3 squared is going to be equal to r squared. 4 squared is 16. 3 squared is 9. It's going to be equal to r squared. 16 plus 9 is 25. That's r squared. Take the square root of both sides, and that's 5. R is 5. Oops. R. So our hypotenuse here is 5. So we've got our opposite, adjacent, and hypotenuse. So we just get all the functions in any particular order, just remembering sine of theta. Again, we don't actually find, we don't have to, at least in this case, find what the angle itself is. Later on we will do that, but we don't need to know what the angle is. We just know that with this endpoint, this is going to be the y over the r, so that is 3 over 5, which is positive, and we know we're in the second quadrant, so it should be positive. We just leave it as 3/5. I guess you could write it as 0.6 if you want for a decimal, but we'll leave that. I'll go ahead and do the cosine over here. Cosine is going to be the x over r, which is negative 4 over 5. And again, cosine in the second quadrant is negative, so that's looking good. And then I like to do the reciprocal functions right underneath. So sine goes with cosecant, and it's simply going to be the reciprocal. So if sine is 3/5, cosecant will be 5/3. And cosine goes with the secant. That's its reciprocal function. And again, negative 4/5 is just going to be negative 5/4. So just flip it. And then we do the ratio functions. So the tangent is going to be y over x, right? The opposite over adjacent, and that's going to give us 3 over negative 4. So the tangent's negative in the second quadrant. That's good. And then cotangent is just the reciprocal function. So I just flip the fraction, negative 4 over 3. Make sense how that works? Okay, so they just give us an endpoint for array. We take that, set up the triangle, and we can get all 3 sides of our triangle from that.
Have you ever done this, memorize like the triples?
Some of them 3, 4, 5. I do remember that one. I don't. Some of them I'll stumble on them, but it's helpful because then you don't have to go through the Pythagorean theorem all the time. But they don't stick in my memory except for 3, 4, 5. 3, 4, 5 I remember. In fact, I had some tile work done, and my contractor, he has a rope, and he has knots. One is 3 feet by 4 feet by 5 feet. And he didn't know he was using the Pythagorean theorem, but he says, yeah, when I lay this out as a triangle, I can tell if I've got square, because this is exactly 3 feet, 4 feet, and 5 feet. I don't know the math. I says, that's called the Pythagorean theorem. He goes, oh, okay. But so people use this, because if you make a triangle with 3, 4, 5, he would know that if it didn't meet, if it was too far this way, he'd have to make his adjustments this way. If it was, a gap, he'd have to adjust the other way. And he did it a large enough one because he says, when you're laying tile, if you're off a little bit over here, it's a lot over there. And he could be very accurate with this little rope with a couple knots on at the appropriate places. So it's kind of cool. So consideration of the signs, kind of just what we did. And again, because everything is tied to the XY coordinate system, you don't necessarily have to memorize these, but just think in terms of that. Remember, sine is tied basically to the y coordinate. So wherever the y coordinate's positive, sine is going to be positive. Wherever the y coordinate's negative, sine is going to be negative. Cosine is tied to the x coordinate. So wherever this x is positive, cosine is positive. Wherever x is negative, cosine is negative. And the other functions kind of follow suit. So we see here the sine and the cosecant go together, just like, because they're reciprocal functions, so they're going to have the same signs. Cosine and secants, they're going to have the same sign. And then tangent and cotangent, because of the ratio function, if both sine and cosine are negative, the ratio functions will actually be positive. And where they're both positive, it'll be positive. Where one sine is 1 and the other, that's where they're going to be negative. So just kind of, I've never memorized all of this. I just kind of think in terms, each time I go through and I think about what these are. And just remember, tangent really is y over x. So it depends on, if they're both negative, it's going to be positive. If they're both positive, it's going to be positive. It's only when the signs are opposite that these ones are negative. And then the cotangent is basically the same thing, but it's the reciprocal x over y. Okay, so where this comes in is we're going to have you, we'll give you two pieces of information, and one of those pieces of information will tell you one of the functions, like this one, that cotangent is less than 0. Well, there's two places that happens. Cotangent is less than 0 in the second quadrant. It's also less than 0 in the fourth quadrant. So we have those two places. But then we give you sine is positive, and so that happens in two places, but there's only going to be one. So sine is positive here in the second. It's also positive in the first. Where do we have an overlap? Well, it's got to be the second quadrant. Okay, so sometimes we get this. You'll see that there's no place where both of them, there's only one place where they both would match up. Okay, so part of this is we get to do this extra piece of information. Is that good so far? Okay. And again, it's just kind of keeping track of where x is positive, where y is positive, and that kind of stuff. So here's where we use it. You'll get problems like this. So they're going to give you some value, like cosine is 2/7. We know that. We'll see how that'll help us set up a triangle, right? And then they will tell us that tangent, in this case, is less than 0, so that's telling us tangent is negative. So there's two quadrants where cosine would be equal to 2/7. Two places where cosine is positive, right? It could be either the cosine is positive over here, because that's where the x is in the first quadrant, but cosine is also positive in the fourth quadrant. So where do we put our triangle? Well, now we have to figure where is tangent going to be negative. Less than 0 means negative. Well, in the first quadrant, both x and y are positive, so it's going to be tangent would be positive here. Tangent is negative down here. So this is the quadrant we want. This is where we want to put our triangle. And remember, cosine is going to be x over r. So our triangle will go to 2. And then it'll go up here, not necessarily to 7, but what we do know is that the hypotenuse will be 7. See, if the hypotenuse is 7, that means that y has got to be a little bit less than 7. I'm not quite sure. We'll figure it out. My lovely triangle. Let me draw it up here. But I've got it down in this quadrant. We know that this is 2 from this part, and that because this is right, this is going to be x over r. The hypotenuse would be 7, and so now we can figure out what that missing side is, what the y coordinate is, right? Using the Pythagorean theorem. So in this case, the hypotenuse is 7, so that's going to be 7 squared equals 2 squared. We'll just call that the y plus y squared. So this is going to be 49. 2 squared is 4 minus 4 equals y squared. 49 minus 45. Yeah. The square root of both sides. Square root of 45 is, yeah, so 45 is 9 times 5. So we can take the square root of each part. So square root of 9 is 3. Square root of 5 is still square root of 5. So part of it is they're going to want you to reduce square roots. And again, so one of the things you'll want to know is your perfect squares. 3 squared is 9. 4 squared is 16. So you look for those kind of factors. That's what y is. Now, is this number going to be positive or negative? It's negative because it's in the fourth quadrant. So I want to list that as a negative value. So this is negative 3 square root of 5. Okay, so I've got my triangle set up. I sort of use that information to figure out what quadrant it's in. And so I kind of, draw a little thing like this. Okay, yeah, everything's lined up. Now I can go get the information they want. They want me to find what's the sign. Sign is going to be, and as I've got this set up, it's going to be x over, or sorry, it's going to be y over r, right? So sign is y over r. So that's going to be negative 3 square root of 5 over 7. Done. That's the answer. We don't have to find theta. That was one of the things I struggled with, as I would think, okay, now I got to find theta. No, we don't. We just have to find sine of theta. Sine of theta is this number, negative 3 square root of 5 over 7. Okay. Find the tangent. Remember, tangent's going to be opposite over adjacent. So tangent is going to be negative 3 square root of 5 over 2. And that's done. We have our answers. Okay. So we use the fractions to help us set up seeing them as sides of a triangle, right? Helping us set up that triangle. We use the Pythagorean theorem to get the missing side, whichever that is. And remember, sometimes with that Pythagorean theorem, you square them both and add them if they're the two legs. But if one of the informations we have is the hypotenuse, we're taking the hypotenuse minus the square of the leg. So just follow through with that. But those are now how we can do any angle, any radius, with just a little bit of information. Questions? Okay. Reference angles. And again, I think the best way to think of this is from the measuring triangles. I think I talk about it. It's been a while since I did it, but you could be in any quadrant, but basically it tells us whatever those values are from the first quadrant. That's what this thing, it doesn't mention the first quadrant, but it's a positive acute angle formed by the terminal side of an angle in the x-axis. So what that means is wherever we are, we can draw the triangle, and the values that are on this coordinate are the same as would be for the same triangle repositioned in the first quadrant, right, where these angles are the same. But the values, but then we have to pay attention. The signs may be different. They may be positive or negative, right? So we keep track of that. But it allows us to basically use just that first quadrant of the unit circle to get the answers for those special angles. That's what we're going to do with this. So find the reference angle for 207. Getting the reference angle in itself is not a big, well, how do we do that? Well, what's 207? Well, again, we come here. This is 0. This is 90. This is 180. This is 270. And then again, this could also be 360, right? Go all the way around. So 207 is bigger than 180. So I'd sort of draw it here as a triangle. So this angle all the way over here is drawn as 207. But what I want is I just want what is the measurement of this little angle of the triangle, right? Can you see that that's going to be 207 minus 180, right? Because so this all the way over here, we subtract off the 180. We'll get that it's a reference angle of 27 degrees. So that means we could use, if we knew what the sine and cosine of 27 degrees are, we could find that it would be the same sine and cosine, except they would both be negative because we're down in the third quadrant. Question? How do you find what? How do we find this one? So yeah, so you kind of put it into the reference that that we're in the quadrant system, and that yeah, we count from 0, 90, 180, 270, at 360. Now, part of what you may be asking is the way to calculate the reference angle is different depending upon which quadrant we're in. Okay, so if we're in the third quadrant, we'll see the way we go about finding the reference angle is we take the angle minus 180 because we want that one. But what if we were in the second quadrant? How would we do that? First of all, let me do the easiest one. If we're in the first quadrant, the reference angle is the angle, right? Like this one. If this was 36 degrees, the reference angle is 36 degrees because we are in the first quadrant. So first quadrant, whatever the angle is, that is the reference angle. Okay. I'll just put a check mark. We're done. We don't do anything. Third quadrant, we take the angle and subtract 180. Second quadrant, again, that would be something like here. So the angle we're given is going here. We want this little bit. So we take 180 minus the angle. So let's see, what would be a good angle here? How about 156? So let's change this and say, and again, I'm just making up one. We take 180 minus the angle that's in the second quadrant. So notice how we sort of switch it, and that would give us what the reference angle be. So what that triangle would look like in the first quadrant. This is going to be, what, 24? Okay, so second quadrant, the subtraction is backwards of how it is in the third quadrant. Does that make sense? Because just think the other one has gone beyond 180 if we're into third quadrant. So we gotta back it down. The other one hasn't quite gotten there, so we're looking for that other piece. And then if we're in the fourth quadrant, let's see what we'd have to do. We do it over here. So that would be a triangle that looked like this. This is the angle we want. The angle we would be given is this whole angle here. So you could see if that the blue angle plus the red angle equals 360. So what we're doing is we're going to, for the fourth quadrant, we always want to take 360 degrees and then subtract the angle, the theta we're given, and that will give us the reference angle. Okay, so, but you kind of have to, again, I don't always memorize how to do this. I think my way through it. But in the fourth quadrant, you're always taking 360 minus the angle. And they mess us up a little bit. Sometimes they'll measure them negatively. So then we switch it over to positive. But those are how we get our reference angles. Okay, so there's basically these three different ways to calculate them. And just remember, anything in the first quadrant, that is the reference angle. Okay. Okay, so far? Maybe? Let's apply it and see how we can use this. Well, I got a picture here that I didn't need. Okay, this is how we're going to use it. So let me give myself a little bit of space here. Clear out that. And I'll clear out this stuff. So where we use it is they'll say evaluate something like sine of 5 pi over 3 using the reference angle. Now if you've got your unit, if you've put your unit circle together, you could probably just look for where 5 pi over 3 is. But let's do what they want. So 5 pi over 3, what you have to think is, in thinking in terms of radians, what is 6 pi over 3? It's 2 pi, right? 6 pi over 3 would be 2 pi. So 5 pi over, 5 pi over 3 is one less than that, right? One notch less. So this is, I want to think of as 2 pi. I want to think of it as 6 pi over 3. So 5 pi over 3 has to be here. And so we're in the third quadrant, or sorry, fourth quadrant, right? Over here is 3 pi over 3, commonly called just pi, but that's how we count around. 4 pi over 3, 5 pi over 3. So we're here. That's the measure angle from here. What's the reference angle? It's going to be this little piece. We take 2 pi minus 5 pi over 3, or 6 pi over 3. That's another way to write 2 pi minus 5 pi over 3 gives us pi over 3. And what that means is that we can use the numbers for pi over 3 from the first quadrant to get all our values for we might need in the second quadrant. So I can look up here at pi over 3, and the x and y coordinates, right, are going to be 1/2 and square root of 3 over 2. And again, if you watch that video, you'll get some practice on creating these values. So the sine of 5 pi is going to be the same thing, but since it's in the fourth quadrant, it's going to be negative, right? So using reference angles, 5 pi over 3 is going to be negative square root of 3 over 2. Okay, and that kind of comes from memory.
Is there any real point to using a reference angle if you got a circle?
Not really. If you got the whole circle, then
Okay.
yeah. So it was like, but they use this, so they have it in the homework, so we'll still teach it. But you're right. It's I guess if you only had the first quadrant, then you can use all the others, so you don't have to make the whole circle. But why not just make the whole circle and say, hey, 5 pi over 3, it's just this. But does that help? Kind of just what the reference angle is, just what it would be in the first quadrant. But if you go ahead and make the whole unit circle, you're going to be fine. But I guess it's just the way they used to teach it was just memorize the first quadrant angles, and then you can get it for all of them. Remember, some of these, I had a trig book from the Civil War era, 1860, and it's just a table of values for all these different angles, but it's only first quadrant angles. So then you get the reference angle, and that's how you would look it up. So that's the thing with education. We're still doing things because that's how they did it 150 years ago. Actually, almost 200 years ago now, right? But okay. Oh, that's all we got to do. So that gets us to the end part. Keep working through the homework. You should have access to it. There was a little problem I had there's some settings I had. 4.2 sort of timed out on us, and a couple of you contacted me, so I clicked the right box that allows you to continue working on it for credit. So you should, and I checked 4.4, so they should all be, and I don't put any due dates. So I also will update homeworks all throughout the time. So if you've got some from previous that you hadn't finished, if you update them further, they'll get updated. The one thing, I don't know. So while it's important to focus on the homework, you can actually do them after the test. They should help you with the test, but we're going to get to the place here maybe over this weekend where you're going to want to start focusing on the review part. We'll maybe do a few of these, but focus on that review that is, let's discard it, the review that's provided by the coordinator down here under exam 2, preparation, exam 2 review PDF, and then there's solutions where she's actually worked them all out on a PDF in different colors, so you can look over that to kind of see how it's done. But these are what I'll use as well on Tuesday to kind of do some of the review. We'll make sure everything's here, but these are just the answers. The solutions actually have them working through each of the problems. So they'll actually show you how, not just the answer. But these are, there's 19 questions, some have multiple parts, but these are the things you'll need to know. And on Tuesday, we'll review that and go from there. So if you want to switch over and sort of focus, because where's the biggest impact on your grade? Is it the homework? No. Although the homework should help you, prepare you to the test, it's the test. So do what you need to do well on the test. The reason I take away due dates, personally, when you get me stressed out or you try to push me to do something, probably why I lost a few jobs. The boss wanted me to go faster. I said, well, you want me to go faster? I'll show you how slow I can go. I'm just that kind of guy. So when I get pressured, I slow down and I react differently. So that's why I said, let's take the pressure off. I'll actually get more done if you don't pressure me. Just don't bother me. Just let me do my job, right? So that's the way I teach. So I want you to not have pressure on you, but I want you to be deciding, do that internal pressure. I know I've got this test coming. What is going to be the best thing for me to do? I'll do that. I can make up little points and stuff later, but if you score solid on those tests, everything else will take care of itself. Let me put it that way. So I want you to be able to do what you know. I guess what's that advertising? You do you. It's a casino thing, but anyway, yeah, you know yourself best. You know what's going to work for you. You do that, and we'll make it all work. So that's all I got for today. Still got a little time if you want. If you have any questions, we can go over those, but otherwise we're in good shape. Any questions? All right, so we'll take a break and you want to stay and work, you're welcome.